Hey everyone, I'm Jenny. In this video, I'm walking you through a solution that Johnny, the CTO of Estuary, has built to summarize Slack threads in a continuous data pipeline that sends the summaries to Google Sheets. This is a great addition to our free and growing ChatGPT playlist of videos, so be sure to check that out. The original blog article can be found here, and the code repository with the solution can be found here. I'll post all of the links in the description box below. In this video, we'll show how you can productionize a custom always-on GPT-enabled transformation pipeline with your actual data. We'll be using Estuary Slack instance to 1. Capture Slack conversations as they're happening, 2. Derive a continuous GPT summarization of each thread's content, 3. Materialize evolving threads and summaries into Google Sheets. Let's first look at a demo of the finished solution. Here's the thread in Slack that we want to summarize, for example. The GPT summary gets sent to a Google Sheet Thread Summaries tab. Now, when somebody adds a response to that thread, a new summary is generated near real time in Google Sheet destination. Let's see another update getting added to the thread. Now the summary gets updated again with the new info. Now let's take a look at the solution. A couple of things to point out. AI pipelines have a context problem. The critical fact to understand about GPT and all trained AI models really is that they are pure functions of their training set and a current prompt. That's it. It's an intelligent but immature assistant that has great recall of its training set, but starts every interaction with horrible amnesia. You can think of it that way. This property is a poor match for the way we represent and work with data records, which in the case of a threaded Slack message look like this. This API response is structured this way for very good reasons. It's a representation designed for a machine, but as a human, we can't really wrap our heads around this. For example, LOL me too, about what? Which channel was this in? What's the context? Who's the user U015FTJ? As you can see, this lacks context. GPT is definitely not going to know the context either. It's not magic, which means that before we can ask a question, we need to piece together the broader task context, joining with other threaded messages, user metadata, and the channel to arrive at a useful prompt. With this rich context, GPT produces a very sensible summary in our output sheet like this. Here's the solution. Conversations are happening all the time, and we would like our spreadsheet to update along with them. We can tolerate some latency, but we would like it to be minimal. We will need to perform a meaningful amount of transformation before we can hand off threads to GPT for summarization. At the same time, GPT has practical limitations. OpenAI offers an ergonomic REST API, but it has fairly restrictive rate limits, which bound the overall API throughput we can utilize. It's also far more expensive than your average API, so we only want to invoke it when the thread is changing due to new or edited message, and perhaps only after first rolling up very closely arriving messages. At its core, this is a pipeline with distinct capture, transform, and materialization phases. We first capture incremental updates from Slack's API, then we transform new Slack records into a full thread context and summarize with GPT. Lastly, we materialize thread summaries to a Google Sheet. In Flow, we can use the pre-built Slack connector to carry out the first part of the solution, capture. We would navigate to the Captures page, click New Capture, search for Slack, hit Capture. From here, you just need to give it a name, determine the number of days to look back into the past to look for messages and threats, and provide a start date. Then authenticate using OAuth and hit next. That's the capture part. Let's have a quick break. Have you ever had a feeling that ads are reading your mind? It's because advertisers are constantly invading your cyberspace, looking through your internet history and getting hold of your most intimate data. Now you can get your privacy back with Surfshark VPN. It blocks invasive targeted ads and shields you from web trackers that gather your data. Additionally, it protects you from viruses, keeping you safe and prevents your identity from getting stolen. But in my opinion, the best benefit is you can connect to other countries' networks to watch shows that you wouldn't otherwise have access to. You can also sign up for Netflix in a country with lower subscription fees, and that easily makes Surfshark pay for itself. For work, I actually had to use VPN once to overcome some restrictions in order to complete a work project. And regardless of how many devices you have, you just need one account to give all those devices access. And Surfshark is one of the cheapest out there. It's running a limited time promotion right now. If you use the link in the description box below, you'll receive an exclusive discount plus your first couple months free. And there's a money back guarantee if you're not happy for any reason. So give it a try, and now let's get back to our learning. The second part of the solution is the transformation. This is where Johnny has already created the solution that you can download from the repo I'll be sharing. But to go over that a little bit, we're composing a pair of SQLite and TypeScript derivations, which are collections that build themselves through transformation of other collections. The first SQLite derivation is responsible for indexing thread messages along with user and channel metadata. When a message is added or updated, the thread's denormalized content is published into the derived collection like this one. This is basically a structured rollup of a current thread state. A second TypeScript derivation takes these structured rollups and formats a text string for the entire thread, which is handed to GPT for summarization, called a completion. Now, derivations have a few properties that make them well suited for this task. First, they run continuously, reacting to new Slack messages with sub-second latency. Second, they're incremental. Derivation lambdas are invoked with new data as it arrives. Also, they're transactional and pipelined. We can achieve more OpenAI throughput by starting multiple API calls, only waiting for them to complete once the transaction starts to close. Also, they reduce data volumes. Multiple thread updates processed in the same transaction are automatically combined into a single output, which means a smaller OpenAI bill for you. Also, they're fully managed. We don't need to provision any infrastructure to run them. And lastly, they're composable. We can create future GPT tasks which draw from the same collection of structured rollups. Again, this part of the solution, the full flow specifications for this pipeline can be found in the Git repo link below. The last part of the solution is to materialize the summaries into the Google spreadsheet. Again, you would go to Flow, navigate to the Materializations page, click New Materialization, hit Materialization under Google Sheets, click New Google Sheets Materialization, and then all you got to do is give it a name and the spreadsheet URL, then authenticate. From the Available Collection dropdown, pick the derived collection from Step 2 and hit Next. Save and publish. After the materialization is set up, you will see the live updates coming in to the spreadsheet with the summaries, thread links, timestamps, channel name. Now, we went through a deliberately basic GPT prompting technique for this demo. Summarization, while useful, is barely scratching at the possible use cases of a pipeline like this. Other use cases include tracking work streams discussed in a thread with descriptions and owners, updating a CRM system with relevant customer discussions in Slack, materializing whole Slack threads into Pinecone with semantic embeddings, then build question answering applications on top of your organization's institutional knowledge. Proactively identifying when a discussion in Slack can be informed from the existing body of institutional knowledge, and monitoring for security and regulatory compliance. So that's it. Again, remember to check out Johnny's original blog article on this. Thanks for watching. Subscribe to this channel for upcoming content on how to start or build a career in tech, how to automate using low-code RPA, how to build real-time low-code data pipelines, and other tech content.